The Apollo 4 mission, unmanned first flight for Apollo Saturn V, space vehicle for the manned lunar mission, launched into Earth orbit on November 9, 1967. The Apollo Saturn V stands as high as a 36-story building and weighs more than a U.S. Navy destroyer. Its Earth orbital payload is 10 tons greater than John Glenn's entire Mercury Atlas space vehicle of 1962. It is moved from the most voluminous building in the world, the most massive mobile equipment ever built. It is watched over in the greatest detail by one of the complex arrays of facilities ever constructed. It answers to a world-encircling chain of electronic eyes and ears and flies a course dictated by the greatest computer capability known. Altogether, the space vehicle, the facilities, the technological team, in short, our manned lunar mission capability, constitutes the creation of some 400,000 Americans. We had chosen to launch the entire space vehicle in the first mission, rather than follow the step-by-step approach of earlier programs. Looking at an illustration of our Earth as it would be viewed from high above the North Pole, we may see the planned course of Apollo 4, 2 circular orbits and 1 elliptical orbit. In addition to the liftoff from the Kennedy Space Center, the first, second, and third stage burns and insertion into circular orbit. High points of the mission were to include the reignition of the Saturn V S4B third stage over the western Atlantic, the first spacecraft propulsion system burn over the eastern Atlantic, the more than 11,000-mile peak altitude of the elliptical orbit to be reached over the Indian Ocean, the second and longest spacecraft propulsion system burn over the western Pacific, then the re-entry, and finally the landing in the Pacific, a few hundred miles northwest of Hawaii. During the 25,000-mile-per-hour entry into the Earth's atmosphere, the spacecraft will, as in the lunar mission, be guided along a roller coaster-like flight path, heating as it encounters the atmosphere, cooling as it climbs back toward space, reheating as it again plunges into the atmosphere for the final descent. Countdown for launch was initiated at the Kennedy Space Center at 6 a.m., November 7, 1967, with liftoff scheduled to occur precisely 49 hours later. Almost inexorably, launch operations moved forward. Minor problems were encountered but readily solved. Although Apollo 4 was tested more persistently than any previous American space vehicle, there were no indications of system malfunctions. The delays, so familiar to us in the early missions of previous programs, simply did not occur. Almost exactly at the planned instant, the Saturn V ignited. Apollo 4 lifted off at 1 second after 7 o'clock, November 9, 1967, with its first stage delivering 7.5 million pounds of thrust. Two minutes and 32 seconds later, just as scheduled, the first stage burned out and separated, having consumed 4.5 million pounds of fuel. The separation and second stage ignition were also recorded by cameras carried on board the vehicle, at this point some 40 miles above the Earth. Additionally, the camera gave engineers a close-up look at another event, the separation of the interstage structure. This was of critical importance because clearances were extremely small between the structure and the engines. For more than 6 minutes, the second stage, which had been a source of major development problems, performed perfectly, hurtling Apollo 4 to an altitude of more than 100 miles. Like the first stage, the second stage cut off and separated almost exactly on schedule. The third stage ignited and inserted Apollo 4 into a circular orbit, where it would remain for some 3 hours. In slightly more than 11 minutes, Apollo 4 had proven out Saturn V stages that had required years to develop. But the mission was far from over. For now, the orbiting Apollo 4 had to be checked out remotely in anticipation of the next series of events. And ground support facilities had to be evaluated. In addition, flight controllers had to prepare the third stage for its first reignition in space, a capability which must be proven for the Apollo lunar mission. Near the end of this time, one of the few irregularities of the entire flight occurred when data suggested that a valve on the Saturn V third stage had not closed as planned for reignition. But at this point, technical skill paid off. The flight controllers quickly revised the pre-ignition sequence to compensate for the potential problem. And the third stage was fired as scheduled, propelling Apollo 4 into the elliptical orbit. 5 minutes and 25 seconds later, the stage shut down. Saturn V, whose guidance computer had made over 300 million calculations since liftoff, had placed the spacecraft on course. The third stage and a test model of the spacecraft lunar module fell away. The launch vehicle had done its job. A few moments later, the spacecraft's own propulsion system ignited and burned for 16 seconds. Giving the spacecraft the velocity necessary to reach its peak altitude of more than 11,000 miles. The spacecraft was oriented so its heat shield was shaded from the sun, soaking in a temperature 150 to 200 degrees below zero. The contrast between this temperature and the extremely high temperatures of re-entry would put the spacecraft heat shield to an especially severe test. As Apollo 4 climbed toward its peak altitude, a camera pointed out a spacecraft window gave us a preview of what a future Apollo command pilot will see of our planet. These photographs were selected from a series shot every 11.4 seconds during a 2-hour and 12-minute period as the Earth passed in front of the spacecraft window. Apollo 4 reached its greatest altitude, 11,232 miles above the Indian Ocean, at 5 hours, 46 minutes, 48 seconds after liftoff. And began its descent to Earth, responding to the pull of gravity, increasing in velocity as if it were speeding down a long hill. Some 2 hours and 20 minutes later, the spacecraft propulsion system again ignited, burning this time for 4.5 minutes. This burn accelerated the spacecraft toward a re-entry into the atmosphere at 25,000 miles per hour, the speed anticipated for the Apollo lunar mission re-entry. The spacecraft command module, which would contain the flight crew in a manned mission, was separated, then oriented with its heat shield forward. At some 8 hours and 20 minutes after liftoff, Apollo 4 re-entered the Earth's atmosphere. Temperatures on the heat shield, which was less than 3 inches thick, soon reached 5,000 degrees Fahrenheit. This was 1,000 degrees hotter than the launch pad flame bucket when Apollo 4 lifted off. Yet the temperature inside the command module never exceeded 70 degrees. Could we have seen the actual command module following its roller coaster path toward Earth, it would have resembled a meteorite from space. The command module splashed into the Pacific Ocean within sight of its recovery ship, the USS Bennington. Although charred, the 5.5-ton command module, like the entire 3,000-ton Apollo Saturn V, had passed the test. Further, the world-encircling chain of ground facilities and the launch and flight teams had proven equal to the task. Some 8.5 hours after Apollo 4 roared off the launch pad at the Kennedy Space Center, the mission drew to a close. And the nation could take new pride in her technology and a new confidence in her future. That was the triumph of Apollo 4.